In this lesson, we're going to look at sequences, arithmetic sequences in particular. Later, we're going to talk about something called a geometric sequence, and they're just ways of, well, thinking about them is thinking about how following patterns really more than anything. A sequence is an ordered list of numbers. In other words, it's going to follow, well, I'm getting ahead of myself, I guess. It doesn't have to follow a pattern, but it usually does. So it's an ordered list of numbers. Each number is called a term. So each number in the list is called a term. The general form of a sequence goes term 1, comma, term 2, comma, term 3, etc. up to term n. N is the nth, the last number. So if there's 10 numbers in a sequence in the list, then n would be 10. That would be the last number in our sequence. So the subscript just represents the term number. A sequence that has a last term is called a finite sequence. Finite just means it ends. So if it has a last term, it's finite. A sequence that has no last term, if it goes on forever, it's infinite. So let's just jump right into getting familiar with the terminology a little bit. Examples are usually the best way to see what's happening. So what are the first three terms of t sub n equals 3n squared minus 4? Okay, so this is what we call the general term of the sequence. In other words, it's a formula that tells us how to create the sequence. So it's a list. N stands for natural numbers. So if you think back to your number set, what you know about number sets, natural numbers are ones that start at 1 and go up by 1. So natural numbers are the numbers 1, 2, 3, 4, 5. We use those for counting things. So if I had a list, just to go off topic for, or not off topic, but off this example for a second, say I just had some random list of numbers. There's no rhyme or reason to this one, but I just want to give some numbers. Okay, so this could be a sequence. This would be the first term, T1, because it's literally the first number. This would be T2. This would be T3. So literally T standing for term, and then the number where you find it. This is the first one. It comes first in the list. This is the second one. It comes second, and so on. So t sub n, again, would just be whatever my last number is, or an unknown. Think of n as an unknown in this case. So it's saying that whatever term number we have, we plug that number in, we're going to square it, then we're going to multiply it by 3, then we're going to subtract 4. So it's almost like using function notation. So term 1 means that n equals 1. So I'm going to put 1 in for n and find out what t sub 1 is. 1 squared is 1, times 3 is 3, minus 4 is negative 1. So t sub 1, that's a unit, right? That's just a t, it's a variable t, but the subscript 1 is just telling us which number it is. So it's the first version, the first value of t. The second value of t subscript 2, is going to be 3 times 2 squared minus 4. 2 squared is 4, times 3 is 12, minus 4 is 8. So t subscript 2 is 8, and t subscript 3 is going to be 3 squared times 3 minus 4. So I'm just plugging these different values in for n. Maybe what I should be highlighting is the 1 and the 2 and the 3, so that you can see what where it's coming from. So 3 squared is 9, times 3 is 27, minus 4 is 23. So these are the first three terms of the sequence. If I was to write it out as a sequence, I'd write it negative 1, 8, 23, and then it could keep going. But this question doesn't ask me to have it do that. Determine a rule for the following sequence. So often there's a pattern. There isn't always, but the ones that are more interesting follow patterns. This one's definitely following a pattern. At a quick glance, I can see that it's going up by 4 from 3 to 7, up by 4 again, up by 4 again. So one of the most basic patterns is just increasing or decreasing by a regular amount. So again, if I want to write this as a formula, rule, when we say rule, we're really thinking sort of like a formula, right? I mean, we could do it in words. I could say add 4 to each number. But if I want to make it more elegant math-wise, I could write it as t sub n equals something plus 4. We know there's a plus 4 involved. Since it's always the same thing. I have to have a starting point, though. So, and it should, if it's going to be a general rule, it should involve this n somehow. I mean, I could just put, if I just put n in here, then when n equals 1, the first term I'd get would be 5, wouldn't it? So that's not so good. What about if I, instead of putting n in here, what if I put, so I want the first term to be 3, don't I? So if I put n minus 2, does that work? 1 minus 2 would be negative 1. Negative 1 plus 4 would equal positive 3. Does that work? No, that doesn't seem to work either, does it? Because if I put 2 in there, then 2 minus 2 would be 0, and I'd get 4 for my second one. So, what's going on here? It's not always super easy to see what the formula is. Maybe a better thing to do would be, instead of adding 4 on the end, maybe if I multiply 4 by n and then add the difference, right? So if I put, if my first term I put 1 in for n, then 1 times 4 would be 4, but now that's 1 too high. Maybe I should subtract 1. Well, let's try it out. If I put 1 in for n, using this formula, then I'd have 4 times 1 minus 1 would give me 3. Okay, that seems good. What if I put 2 in for n? Well, 4 times 2 minus 1, that would be 8 minus 1 would be 7. Looks like we're on to something, right? So there is a pattern. If it goes up by the same thing all the time, then we can usually find some sort of pattern, although it may not be initially completely intuitive for us. But through a little trial and error, I was able to find the rule. So it turns out that if I were to multiply the term number by 4 and then subtract 1 each time, then I could get each number of the sequence. So the fourth term would be 4 times 4 minus 1, which would give me 15. An arithmetic sequence is a sequence where each term increases or decreases by the same amount each time. This increase or decrease is called the common difference, and we know about differences from doing linear and quadratic differences, so that's not something new to us. And it's represented by the letter D. This leads us to the formula to determine the general term of any arithmetic sequence. T sub n equals a plus n minus 1 to n minus 1 times d. Well, let's see where this formula comes from. The development of this formula starts with the general idea of an arithmetic sequence. So if we let a be our initial value, okay? So a is our first number. Let a be the first term or first number. So if we know where we're starting, so we're going to start with a. And then if it's going up by the same amount every time, like 4, the second term would be a plus 4 in this case, or if d represents how much it's going up by, it'd be a plus d. And then the next term, we already have a plus d, and we'd have to add d one more time. And then we'd add d, the next term we'd have a plus d, we'd add d one more time. So we just keep adding d to get our next term. That's what this is saying. If I simplify this, then of course I have a and I have a plus d, but this next one here, a plus d, could be simplified as a plus 2d. And this next one here as a plus d plus, do it in blue. A plus D plus D plus D would be A plus 3D, and so on, right? So we can see there's a pattern going on, and we can simplify it. It turns out that the first term is always A, and as far as the D's go, the D's don't start until the second term. So if I want to know where the second term, or if I want to know for any particular term how many D's I've got, I just need to take the term number and subtract 1. So in the second term, I'd have 1 D, 2 minus 1. In the third term, I'd have 2 D's, 3 minus 1. And you can see that just by looking at the example above here. We've always got 1 less D than there is the term number. So when we put that all together, we get this formula. T sub n equals A plus n minus 1 times D, where A is the first term, n is the term number, and D is the common difference. So let's work with this formula, see what we can do. Given the sequence -9, -6, -3, 0, determine if it's arithmetic, and if so, what's the general term. So we want to see, we're going to look to see if we can find a common difference. Going from -9 to -6, picture a number line, we're going up by 3. Going from -6 to -3, well, we're going up by 3 again. And from -3 to 0, up by 3 again. So it seems as though there is a common difference if the pattern holds. So this would be, we can tell that D equals 3. We also know what A is. A is the first term, as already identified. So A would be -9. So actually, it's pretty easy to come up with a formula. T sub n equals -9 plus n minus 1 times 3, using these different values that I just identified, right? And usually we'll simplify this, though. So I could collect like I could expand it out and collect like terms. I could multiply n -1 by 3. So I'd have -9. So let's go back to blue here. I could have -9 plus 3n minus 3 when I expand that 3 into the brackets. And if I collect my like terms and then put the n's first, I'd have 3n minus 12 when I combine -9 and -3 together. So this would be my simplified version of the formula. And by the way, I didn't actually write it down, but it said determine if it's arithmetic. Yeah, it's arithmetic, right? Because it has a common difference. Is 11, 22, 44, 88 an arithmetic sequence? Well, the first time it goes up by 11, then it goes up by 22, then it goes up by 44. No, this is not an arithmetic sequence. Because there is no common difference. Without a common difference, it's not arithmetic. There's definitely a pattern going on, but instead of adding the same amount each time, what I'd say is going on is that it's actually multiplying each time. 11 times 2 is 22. 22 times 2 is 44. But that's not arithmetic. That's actually a common ratio, and that's going to be something that we look at in our next lesson, which is geometric sequences. Determine the 25th term. There should be an R in there, shouldn't there? Of -17, -10, -3, 4. So, well, first of all, is it arithmetic? Goes up by 7, goes up by 7. So it's going up by 7 each time. So D equals +7. The first term is -17, so that's easy. Easy enough to come up with a formula. So it's -17 plus n minus 1 times D, which was 7. If I do the distributive law again and expand this out, what I get is negative 17 plus 7n minus 7. Collecting my like terms, I get 7n minus 24. And then if I want to find the 25th term, that just means I'm going to let n equal 25. So I'd have 7 times 25 minus 24. $151. That would be the 25th term. How many terms are in the sequence 3, 15, 27, 495? This is a finite sequence, right? It has an end. And if it's arithmetic, it must have a common difference still. So 12, 12. It's going up by 12 each time. Okay, so D equals 12. And A is 3. So let's just ignore the 495 for now and come up with a formula. We've already done it a couple times. T sub n equals 3 plus n minus 1 times 12. Again, I like to simplify it. So if I do the distributive law here, multiply each of these by 12, I get 12n minus 12. So again, in simplified form, it's 12n minus 9. There's my formula for this sequence. If I want to find how many terms there are, that's going to equal n, right? There's n terms. I just don't know what n is. I have to solve it for n. But the good news is that I've got a formula now that I can use to solve it for n, because I also know that however many terms there are, this 495 is the nth term. So in other words, T sub n equals 495. And I can plug that into this equation, replace T sub n with 495, and solve it for n now just by rearranging. I'll add 9 to both sides. That will give me 504. And then I'll divide each side by 12. And whatever I get for 504 divided by 12 is going to be equal to n. (42). N equals 42. So there's 42 terms, because again, whatever n is has to be my number of terms. T sub n is my last term. Now that I know that n is 42, then I could say that it's T sub 42 is term 495. Or T sub 42 is equal to 495. My bad. For the arithmetic sequence given, or for an arithmetic sequence, determine A, D, and T sub n. So what if they give me what the 6th term is and the 11th term? But they don't tell me what's in between. So I know that we got 5 terms, and then we've got the number 23. Then we got 5 more terms, I guess. 7, 8, 9, 10. 4 more terms. And then I've got 38. And probably it keeps going. I'm supposed to find out what the first term is and the common difference and the last term. Well, the easiest way to do it is sort of like thinking about it like it's a slope almost. If I think of this like an ordered pair, n and T sub n, then I'd have this ordered pair 6, 23, and I'd have another ordered pair 11, 38. If we do it like a slope formula, I could do 38 minus 23 over 11 minus 6. That's going to give me my constant difference, because my constant difference is like my slope. So 38 minus 23 equals 15. 11 minus 6 equals 5. The common difference must be 3. It has to be going up by 3. Sorry, 3? Yeah. 3 each time in order to get between 23 and 38 going at a constant rate. So once I know that D equals 3, then I can work backwards, and I know that, all right, if d equals 3, then the first term, let's do it this way. Let's write t sub n equals a times n minus 1 times d, or plus n minus 1 times d. Let's fill in what we know. So I've got a plus n minus 1 times 3. If I pick either one of these ordered pairs, just like we do in back in grade 9, I can plug in and find out what's missing. So let's say I plug this in for n and t sub n down here. Well, that means that when t sub n equals 23, that has to be the 6th term. And I can solve to find out what a has to be. So that's 5 times 3 is 15. I'll just write it like that. And then I can subtract 15 from each side. And a had to be 8. So it's working backwards using what we have. It's more elegant than just counting the terms in between or counting down to the first term. This actually shows my work. So now I know what d is. Now I know what a is. And I'm supposed to find out what t sub n is. So I can put it all together to get my formula. So it's well, let's write the formula one more time. So it's a is 8 plus n minus 1 times 3. Do my distributive law thing again. And I have 8 plus 3n minus 3. Collect my like terms. 3n plus 5 would be my final answer. Maybe I'll write t sub n down here as well just to round it out. So there's my actual formula.